go. Well, thank you very much for joining. And as already mentioned, we're going to be having a little bit of a look at photo engraving. So if you're watching, then please obviously be interesting to know kind of what businesses you are working with and what you'd actually be looking to engrave in terms of the photos. So do ask questions away in the chat throughout this. And then at the end of this, we will be doing a question and answer session. But as already mentioned, the idea behind this is to hopefully give you a little bit more of a guide. So we couldn't really cover every material and the best way to do everything. So this is really to give you kind of maybe a structured approach to looking at working with photos. So to do that, we're going to be looking at 6 different tips in terms of your workflow. And then at the end, we'll be finishing off with the question answer. Hopefully this will be about 25 to 30 minutes with 10 minutes at the end for the question and answer. So let's have a quick look initially at some photos. So here we've got some examples of some photos that have been engraved. Obviously what we're looking at here is some very different materials. So we've got things like glass, plastics, acrylics. You can also engrave onto wood. Really anything that you can laser onto normally, you can use for doing photo engraving, but there are some differences in the material. One thing that is worth noting when you look at these examples is actually that the backgrounds have been removed, especially from some of the images. And essentially that's going to allow you to have some better contrast. So also when you're looking at doing photo engraving yourself, have a look at what other people are doing as well. It's quite easy to search on the web and get an idea of, what kind of does work and what doesn't work. So let's start off by talking about your material settings for the actual process itself. It can be quite often thought of that you just, generally when we do our engraving setting, it's quite easy. We just engrave into the material, keep adding power until we get a nice contrast. But quite often what that can end up is we end up really engraving into the material. So by that I mean we're actually removing material, so creating depth into the material. And that's really great for doing things like your basic text, and it does give you a nice amount of contrast. But the problem with this is when we put lots of power into the laser engraving, say we're aiming the laser at little dots, so we're just turning the laser on and off once. If you're using a lot of power, what you'll find is that is actually spreading. So hopefully you can see this kind of red block here. So that's to illustrate that we may be aiming just at this narrow portion here, but because you're using a high amount of power, the dot's spreading. So why is that important? Well, when we're engraving a photo, we're generally working with lots and lots of detailed information. And if each of these dots starts to expand because we're using too much power, all of these little dots start to overlap, and it means that you lose a lot of detail from your engraving. So how do you find the right setting? Well, really what you've got to do is just keep adding enough power that you're really getting some kind of color contrast, and really try to avoid going too deep into the material, because basically it's going to result in you having less definition from the image itself. And also, let me see if I make this a little bit bigger. Over here you can see in the top right-hand side where it says marking, you can see that I've added a little bit of black ink to the material. So some materials you can't always get a great contrast straight away, but there are often other workarounds to kind of bring that information and detail out of the actual material itself. So let's have a quick look at an example. So over here we can see two extremes. So on the left we quite clearly just haven't used enough power. So you can see that we haven't brought out the contrast in the material. And on the right hand side you can see where we've actually used too much power. So as you can see from this image on the right hand side, we're losing all of the kind of the contrast and the differences between the background and the foreground, just because we're using so much energy that all these little dots are overlapping and we're losing a lot of detail from the image itself. So hopefully that's given you an idea of your material settings. We're adding just enough power basically to get some contrast, add some material, but just don't go too high with it. Number 2 is going to seem like a bit of an obvious tip, but a bad picture does result in a bad engraving, and it's something you've really got to bear in mind, especially when you're working with customers' artwork. Quite often you'll find you'll get sent an image and it's just not of a high quality. Now that doesn't always mean that that's the end of that subject. So for example, if you've been emailed a photo or you've been sent a photo via a phone, quite often when the photo is sent to you, it might be compressed. So it might actually be that a high quality version of the photo does exist, but you do have to work with this process. And once you really get some experience with photo engraving, you will find that there are cases where quite simply you actually will just have to turn away work just because you can't get a good result from the image itself. So this really goes back to just real basic setup in terms of more on the photographic side. So for example, if you've been given an image with poor lighting, then of course we can't make data out of something that's not there. If the photo itself is out of focus, then again, we're not going to get the contrast. And again, if the exposure is wrong, we're again not going to be able to get a nice result. So it's very important to realize that obviously with our standard photos that we're working with, we have the color to provide that contrast and that really great look from a photograph. Whereas with a laser, typically, obviously, we're only having that light and the dark from the material. So basically, if you've got a bad photo, it's going to be even worse when you've actually engraved it with the laser. So the final thing, and we will have a little bit of a look at a guide for this as well, but is the actual image size and the quality as well. So here we have this file here. Obviously, it's a vector file, but it gives an idea. It's been converted to a JPEG. And you can see we have two previews of the same file, but at just different resolutions. So you can see at the very top, we have a nice high quality image. And what that means is that when the laser is zooming in onto the material itself, we can see that we have good contrast and good clarity, and that the laser can pick up all of the detail here. Whereas on the lower section, you can see where it's all pixelated. So what does that mean? It means when we actually print that through our laser driver, it's going to start interpreting all of this kind of pixely gray area as blurred data, and that is what it will engrave. So you have to be aware of what the image looks like, not only zoomed out, but also, when you actually expand it up to the size you're going to be working with. So let's have a quick look at some example resolutions and some example file sizes. And you can quite easily see here that when you work with a larger image, essentially it's quite simple. You're going to need a larger file, but with modern day smartphones and other cameras, generally, you can get a very high quality image straight from there. But you just need to make sure that you're not being sent the compressed version. So this is a little guide and a little idea of kind of the file sizes that you do require. So now we've had a look at the actual setup in terms of the material setting, and also having a look at how the kind of image quality can affect things or things to consider. We can now look at the actual patterns and the way we're actually converting that image data. So quite often there can be a little bit of confusion about how we're processing an image, especially depending on what lasers you have access to. Sometimes it's considered that we're processing the image as a grayscale, and that's not what we're doing. So with a grayscale, this example over here on the left-hand side, you can see that actually what we use this for is for a relief pattern. So what that means is where the image is darkest, where it's black, you engrave with more power, and that creates depth, and where it's lighter, it uses less power. So this is a really great effect, but we use this for contouring. We don't use this for photos at all. So grayscaling isn't, well, that's a good way to preview an image. It's not how we're processing it. When we process an image, what we want to do is we want to convert it to a dot style matrix or pattern. So over here on the right hand side, I'll just see if I can make this a little bit bigger again to make it a bit easier to see. You can see that we have some different versions. So over here, what we have is just simply, we've converted the image to black and white data. So if you look at these two columns on the right hand side, you can understand a bit more what's happening. So where the image is darker, so at the top, you can see it's having bigger dots, and they're more densely grouped. And then at the bottom, these dots start to widen out and the dots become smaller. So this is how we need to convert the image. And if you've got a Trotec laser, we actually have a built-in function into our printer driver. If you don't have a Trotec laser, then you can manually do this as well with a lot of different bits of software, and we will have a look at doing that as well manually. But hopefully this gives you an idea that we're not actually converting it to grayscale, we're actually converting it to a dot style pattern. And going back to the material setting, the other reason this is important is obviously we've already chosen at the very start of this our laser power, where when the laser hits the material, it results in color change. So we don't want the grayscale where the power is varying up and down and giving us different results throughout. So let's have a quick look at setting up a file. And if you do visit our YouTube channel, I do actually have an example on there as well. You can just search Trotec Photoengraving, I'm sure it will come up. And on there, you'll be able to see some of the different results. But right now, let's bring up an example of working with an image. So over here, we have the original image on the top left-hand side. And over here, we have kind of what would be the finished article. So getting the image to this kind of state here. And then also I'm going to also show you how to do this manually as well. So over here, we have an example of manually converting this pattern, which hopefully will give you a bit more of an insight as to what we're doing when we're setting up the drawing. So let's just do a quick comparison. So if we have a look at the main photo, the first thing we can hopefully see is that at the edges of the image, it's actually out of focus and blurred. So that's the sort of data that you might want to crop out at the very end of it. But what we're really trying to do here is we're trying to get rid of some of the shadows. So you can see it's quite dark here on the inside of the jacket. And then also what we want to try and do is to improve the contrast. So you can see here on the hat, although we do have some good color contrast between these different layers of the hat, if we look at the final example, you can see how much more emphasized we've been able to make this difference between the highs and the lows. So let's have a quick look at how to do this. Obviously, I'm using Corel Draw for this example, but all of these functions are available in lots of different software. And especially when you look at things like Photoshop, there's going to be a huge amount more of control and things that you can do. So this software is really kind of like the more of the limited side of it. So I'm just going to copy this image so that we can start with the original. And the first thing we want to do is we're just going to have a look at some basic adjustments. So here we're going to be looking at the contrast of the image. So we'll just bring that across, and then we can bring that here. So what we want to do is we want to have a look at these little sliders. So let me just reset this. So this is the image data here, and these are the darks and the shadows. And up here are the highlights of the image up here. And down here we have the ability to remove some of the shadows by compressing the image. And basically what it will do is it will get rid of the data when we move the slider up. So you can see if I bring this up, it's removing more and more of those darker tones. And conversely, if we're at the top here and we bring this down, you can see it's removing more and more of the highlights. So this is a very small and quick and simple change, but what it means is, although it's going to make the image look a little bit washed out, we can start to lighten up some of these dark areas. Now, one thing to bear in mind when you do these basic adjustments is obviously we're not actually going to be printing this image. So what you actually end up with for lasering, you may not look great for a printed image, but should work quite well for working with the laser. And over here, you can see the sky is actually not too bright, but you can see we've got some highlights here. And again, if this was, say, overexposed slightly, you can just get rid of some of the upper edges here, and you can just reduce some of the overexposure, also get rid of some of the shadows. But again, if you're working with something like Photoshop, you can go into this in a lot more detail and actually come into certain parts of the image to adjust it. But you can still get quite a good result with just these basic adjustments. Next, we want to come up into our adjustments and our effects. And you're looking for an effect called an unsharp mask. Now what this is going to do is it's going to look at the highs and lows, so a bright color and a dark color, and it's going to enhance that. And so if we again get rid of the preview and we zoom in here, and you can just see, if I enable this again, you can see what's happening here. So we're really bringing out the contrast between the different colors. And again, this wouldn't look great as a printed photo, but it would allow us the laser driver to pick it up and give us a better engraving. So let's have a quick look at the controls. So the percentage is how much we are applying the effect. So whether we're applying it a lot to the image or only a little bit. Next, we have the radius. So if you imagine that we're using a paintbrush, if we have this at a small number, so it's a low number like the 1, then it's like using a fine liner pen, whereas up here would be like a big permanent marker. So basically it's going to emphasize the contrast even further. And then the threshold is what kind of difference in the image does it need to see to activate it. So if you have this too high, it's going to ignore a lot of the image. But as we start to bring this down, you can see it starts to pick up a lot more of the image. So let's just have a quick look, and you can see even across the sort of details in the face as well, you can see how it's really emphasizing the contrast between the highs and the lows, and all of this is just going to help the laser when we actually send the file across. So from this point, if you've got your Trotec laser, then all you need to do is to go to File, and then we'll go down to Print. And I'll just print the selection. And then in here, we can see we have the different setup. So down here is really what we're interested in. So obviously you choose your material, but here we're going to choose the mode, and here you can see we have photo optimized. You can then set your resolution, which we'll go into a little bit more detail in a minute, but generally you're going to be around the 500 mark. And then here we have the different ways it's going to interpret the data. So this really takes a bit of experimenting, but I would recommend you try something like the sticky filter, or all of them are fairly good to be honest, but it's just some slight differences. So from this point, we can then simply click print, and then it's going to create the file and send it across to the job control. So just bear with me a second while job control is opening up, and then I'll share that across. So let's bring this across into here, and then we're going to want to just quickly find the file, 1 second. There we go. So when we look at the next step, which we're going to look at, which will be manually converting the actual file itself, the main thing that's important to bear in mind for manually converting the file is actually looking at how many lines per inch that we're using with the actual file itself. So here we can see the file, and the Trotec drive is automatically converting it to black and white, and it's very hard to see just on the preview side, but you can see it's converting it to black and white data and dots. And you can see by bringing out the enhancements and using the unsharp mask, which really emphasized the detail, which then is picked up by the laser as well. So from that point, you simply just run the file, and you've got something you can work with. So let's just take a quick little look at how we can manually do this as well. So here we have the image, and we're just going to come up into here, and we're just going to go to bitmaps, into mode, and we're going to turn it into black and white. So that's again going back to the fact that what we want to create is a black and white data for the laser. So the laser is either engraving or it's not. So here you can see it's set up at the moment, and essentially what we're doing to the image is we're converting it to these black and white dots. You can have a little play here with the different shapes that you use for your laser. Generally, I just use the round function. Here you can change the angle. Again, you can just really use this if you have something where you've got some banding to the actual image itself. But the main thing that's interesting and worth experimenting with here is the actual lines per inch. So if you're working with a material where you're able to pick up a lot of detail, then you can obviously have this at a higher number, so say maybe around 300. But what I often find is, especially when you're working with material that's harder to engrave, then I would recommend that you really look at using a lower resolution. So if you think each of these dots, trying to create 300 dots per inch, you know, that's probably 0.2 of a millimeter, something like that. Whereas you really actually want to be down at a resolution, probably around 75 lines per inch or something like that when you're working with wood, just because we need these bigger dots in order to actually see the contrast in the wood. So I hope that makes sense. Just because the wood's less sensitive, you need to use a bigger dot size in order to see that contrasting mark. So it's very easy to try, engrave at 1,000 lines per inch. set the actual image conversion again right up at a really high number, 500 to 1000. But actually, because you've got those dots all so close together, you actually won't see a lot of the detail from the image itself. And again, these previews aren't ever really a great way of visualizing the final result that you're going to get. You really need to run the job on the machine and on the laser to see exactly what you're getting. So I'm just going to quickly bring back up the presentation, and then I'll just have a quick look at some of the questions. But hopefully that's giving you an idea of how you can work and get images across. So again, if you've got the Trotec, then I generally do leave the image in color and just use the built-in method. But otherwise, you can manually play with it as well if you start to get more used to it. So I've just seen we've got a question from Nathan, and does the job control laser software work reliably on a Mac? So with the job control, it doesn't install natively onto a Mac. What you'll need to use, and we actually will have something on this later, is our new Ruby platform. So you'll still have a Windows-based kind of slave computer that will be connected to the machine, but our new Ruby software will allow you to work direct with the machine. That also has image functions built into it, and you can actually remotely get files sent across and set up on the machine. So it is possible to work with a Mac. Let's have a quick look at the other questions. And I think we're good to continue. So again, if you do have any other questions, do ask away. And now we will continue on with the presentation. So the next thing you need to consider with the setup of your machine is the actual material itself. So you can kind of range this quite easily from easy to work with and then to material that's more difficult to work with. So on the left-hand side here, we have material that's really great to work with. So our Trolase metallics, or our just general Trolase material. For those of you who aren't aware, that's an engraving laminate. So we have a very thin layer top coating, and then beneath that we have a very contrasting color. So in this case, it would be a silver onto a black in this example. And what that means is each of those dots that's fired by the laser reveals the black data or the black color below, and you get a really nice detailed image. The same also goes for anodized aluminium, which just works very nicely with the laser. So again, when you fire into anodized aluminium, the beam doesn't really spread at all, and that means that you get a nice, very crisp and clean engraving. So what you need to consider is if you're doing quite small engraving or you're doing very detailed images, especially things like photographs, then working with this type of material is going to give you a much better result than working with something like wood, where every time we fire into the material, the energy starts to spread and we just really can't get as much detail. It doesn't mean you can't get really good results from engraving into wood. You know, it's a very popular material to work with, but it is worth bearing in mind that when you create your products, you do experiment with different materials to see the different results that you can get. And in the middle, we've got things that are painted or are standard acrylics. And again, it's going to depend on the color. So obviously, if you're working with something like a clear acrylic, then you're going to be wanting to have something that actually maybe will give light to those. So I've got, you can see here, this is an example of something I've engraved into some clear acrylic, and it looks really nice, especially if you have it up by a window or something like that. But in order to make this look even better, you know, this is actually designed to work with an edge lighting panel. So this is where you put an LED to the edge here, and it will bring out all of the image on there as well. So it's worth bearing that in mind. And hand in hand with that is considering the actual size of the engraving. So if you're working with a very small product, then you're going to want to use a material generally that's going to be more sensitive. So things like the Trolase or the anodized aluminium. If you're working with a very large product, then again, that's where you can consider working more with materials like woods, because it's that much because you've got that much bigger of an area that you're working with. You can then use that lower, so the bigger dots, and still get a really good result onto that. And the final thing to consider is also to look at experimentation as well. So over here, we've got some examples of different ways that you can process and work with the materials. So on the left-hand side here, we've just taken the image, engraved it into material. Again, I'd say I probably actually want to run this in a slightly lower resolution, but by using a paint fill or an ink fill, we're able to bring out the contrast into the material. This is also a very good technique to use if you're working with a material like wood. You could actually apply a lacquer to the material before you actually engrave into it. Then that way you'll just remove the lacquer and obviously the little dots in the material. And that way, when you take your rub and buff, it's not going to stick into the rest of the sheet of the material, and it's just going to stick into the areas that are exposed. I've also used this technique as well. Unfortunately, I've got an image here, but we're working with materials like marble, and you can almost do the, it's very popular, like the kind of a paint by numbers type thing. So obviously, in this case, I'm just adding one color. In this case, it's black. But if you have a large enough image, you can actually start to add back color into an engraved image. So you can pick up different parts of the image and start to add the different colors. Unfortunately, I haven't got the artistic ability to be able to pull something like that off, but I have seen people do it, and it does come out really, really nicely. And again, here we can see that we have the same image again, and you can see we can start to pick up a bit more detail by enhancing the contrast. And finally, on the right-hand side over here, we have the coating that we've applied to the top of the material. And what that has done is, again, we're engraving through the paint to reveal the wood underneath, and it creates a really good effect. So I think that's something that really you have to bear in mind when you create these kind of products, especially with photos. It's very easy just to get excited when you first get a laser and have you create a file, you send it to the machine, you hit go, and you just don't get that good of a result. But actually, by taking a bit more time to experiment with different finishes, the different materials, it does take quite a lot of time to do. But once you start to get used to it, then it's something that you can normally perform it and do quite reliably as well. So the final thing we're going to cover is, if photo engraving is something that you really are looking to do and you really want to incorporate into your business, is you really do need to make sure that you take very much, as much setup time as possible. So we'll just talk a few little points here. So the first thing is that your material has to be in focus. You can get away with, if you're doing block text and other type of engraving, with having a material that's not perfectly flat. But this over here is just a little example. So you've got the laser beam across here that's coming down to your focus point, and if your material is not flat, say it's coming up to this point here, again, you've got a really wide laser beam length around the focus, and you're going to lose all of that detail. So it's not going to be a good result, no matter even if you've got a great setup on the picture and everything else. The same goes for the material being flat, so anything that's warped. So if you're working with woods, then particularly you need to take care with how you store your material before you engrave into it. Or maybe you want to actually, if you're just engraving it, bond it to something like an aluminium plaque or one of our engraving tables so it doesn't warp at all. And then the next thing to consider is the actual lens. So especially if you have a flex laser, then you might be using a 2.85 inch lens, and that's going to have relatively quite a big dot size compared to something like the 1.5 inch lens, which I would recommend for your photo engraving. So again, you can think of it like the difference between using a fine liner and a paintbrush. So if you've got these nice small lens, you've got a nice small dot, and you can get a lot more detail from an image. Whereas if you've got a much bigger dot from using something like a flex lens, then you're not going to be able to get as much of a good result. Finally, make sure extraction is set correctly. So what you want is, you want to make sure that when you're engraving into the material, that all of the surface of the material is still clear. So this generally comes if you're using too much power, but quite often I've seen it where you have too much power into the material, you get a lot of dust and debris and dirt sticking to the top of the material, and then the laser's having to engrave through that in order to get the contrasting mark. So you can imagine, obviously, that's effectively going to be like having slightly less power if the material is really dirty on top. So you do want to make sure you have the extraction focused. And the simple way to do that is basically blank off the rest of the bed and make sure the extraction is focused just around that engraving area. And the final thing to consider is, do you need to run at maximum speed? So this really especially applies to anyone who has glass laser technology. So if you have a glass laser, they tend to be kind of 20 to 30 times slower at firing than an RF ceramic or laser. And what that means is when the laser head is flying across the top of the material and you're asking it to fire all of these little pixels and bits of data, the laser just can't turn on and off fast enough. It then starts to skip dots, it then starts to have too much power from the laser shot before, and then it will put in too much power in the next dot. Basically, it just results in a really bad engraving. So you will actually find there is a performance benefit with photo engraving by slowing the machine down. So if I'm doing basic text, then especially with ceramical laser, I tend to be running that at its maximum speed. It's very easy to engrave. But if you're doing things like your photos, it actually is worth experimenting. Just try halving your normal engraving power and your engraving speed, then try quartering it. Obviously, it's going to take a lot longer to create the actual artwork and the graphic. So obviously you have to account for that in terms of your pricing, but you can actually find you can get better results by slowing the machine down, giving the laser tube more time to fire, because we're trying to fire at little dots of pixel data, and you just really need to give the machine as much time to do it. But obviously that's going to increase the cost of the products. But hopefully that's given you all an idea of the kind of workflow that you're going to use. So a quick summary is, first of all, make sure you're not using too much power. So just mark the material, don't engrave too deeply into it. Number two is to use a suitable image. And actually coming back to using a suitable image, if you do find a really good photo, so you create a really good engraving with a photo, make sure that you keep that photo, because then you can use it on different materials and then start to play with different settings and different parameters. And in that way, you can be sure that the bad result you're getting isn't actually down to the material and it's down to the image. So you want that nice steady base image to be able to work from. And again, anyone who's searching, you can also use HDR filters. If you have a look at that as well, that's a good way to improve your images as well. Next, we're making sure to use a raster pattern. So again, if you've got a Trotec laser, you've got that built in through either job control or through Ruby. You've got that built in with your software. Again, obviously, I've shown you a little brief introduction of how you can manually do that by converting it to black and white data. Next, you need to make sure that the material you're working with does provide that contrast in the first place. And then, of course, making sure that that goes hand in hand with the size of the engraving. So trying to do very small engraving into wood isn't going to give you a great result. And then finally, just make sure you take the time to set up your machine correctly. So focusing on using the smallest lens that you have available, checking it's all in focus, the material's flat, and everything else. So hopefully that has been useful. Of course, you can follow us on social media, and there are obviously other tutorials on YouTube for this. And if you do have any questions, then please do ask away. So let's have a quick look across to some of the questions and we'll see what we have here. Let's have a look. So I can't see any questions at the moment. Don't be shy, feel free to ask away. If I can't answer it, I'll defer it to Brian when he comes back. Let's have a quick look. Does anyone have any questions at all? No, looks like we have nothing here. So I think Brian is going to pop himself back into the chat instead.
We had one question.
Oh, and he's still. I like it when Brian's muted. It's much easier on the ears.
Can you hear me now?
No, still can't hear you, Brian.
I shouldn't be muted.
I've just seen one question coming in about, does this work on Mac? So for working with a Mac, you're going to need to look at using our Ruby control software. So you'll still actually need physical access to a Windows-based computer. So that needs to be connected to the machine, but essentially it'll just be sat there. And then you can work straight from Ruby, and you can create all of your artwork, graphics, and then have that run on the machine. I've got a question about cutting for paper. Interestingly, this actually probably links to another topic, but It's really going to depend on the machine you've got. With our latest Optimotion and our brand new 100, 300 and our 400, we can really cut very fast indeed. So should be holding other webinars on that topic, but I'm just trying to think of.
We will be
25% speed, so it must have always been up at about nearly over it, where it would have been over a meter a second on some of the cuts. You can get a really good result, and that's down to the ceramic ore as well.